Here I selected Raoults law in two forms. First form of Raoults law. It is for two volatile liquids. Here I am taking a vessel and filled it into or liquid into that vessel. The liquid is labeled as A type of liquid. Here some pressure is developed from the vapor. So the vapor pressure of the liquid is PA. It is in pure state, so it is writing as P0A. I am taking second vessel and filled B type of liquid here, pure liquid. This liquid creates some vapor pressure. It is taken as PB0. Yeah, B type of liquid. Now I am mixing together A type liquid and B type liquid. Here A molecules and B molecules are present. So here it is solution. The mixture of two components A and B gives a solution. Here A component releases vapor pressure PA. It is called partial vapor pressure of the component A, and B creates vapor pressure of P. It is called partial vapor pressure of P. Here PA and P0A is different. PA is the vapor pressure of the liquid in the solution. Here P0A is the vapor pressure of the component A in pure state. So this is the difference. From Dalton's law, the total pressure of the solution is equal to sum of the partial pressures which are present in the solution. The total pressure is taken as P total is equal to sum of the partial pressure. There are two components, PA and PB. This is Dalton's law. From Raoults law, the partial pressure of a component is equal to is directly proportional to the mole fraction of that component. It is called as Raoults law for two volatile liquids. The partial pressure of a component is directly proportional to the mole fraction of that component in the solution. It is called as Raoults law. The partial pressure of component depends on the mole fraction which is present in the liquid or which is the solution. Partial pressure related to solution. Partial pressure of A is directly proportional to the mole fraction of A. So partial pressure of A is directly proportional to mole fraction of A. To remove this proportionality, we have to multiply with constant. Pa is equal to K into Xa. In a binary solution, sum of mole fractions is must be equal to 1. If I am taking XA is equal to 1, then XB becomes 0. We substitute in the place of XA 1, 1 plus XB is equal to 1, XB is equal to 1 minus 1, that is 0. Which means there is no second component present in the solution. So XA is present alone. So XA creates XA is equal to 1, it is substituted here, and K is equal to PA. Here PA is taken as P0A. P0A is equal to K. PA is equal to P0A into XA. In the same method we apply for B component also. Here PB is equal to P0B into XB. These two values are substituted here to get the final formula. P total is equal to in the place of PA, P0A into XA. XA mole fraction of A component, or zeta A. P0B zeta B. This is the final formula. To calculate this, using this formula, we have to calculate total pressure of the solution. Okay. So I take in a graph for this Raoults law. It is y-axis. It is also y-axis. Left hand y-axis and right hand y-axis. This is the x-axis. I am taking graph between. Mole fraction and vapor pressure. Vapor pressure taking on y-axis, mole fraction taking on x-axis. Mole fraction. Here, for component 1 or A, mole fraction is equal to 1. Gradually it decreases towards right hand side. 0.9, 0.8, 0.7 or 0. Finally, XA becomes 0 here. Here also vapor pressure. From this Raoults law, the partial pressure of a component is directly proportional to mole fraction. Initially, the vapor pressure of the pure component PA0 here, both are directly proportional. If the mole fraction decreases, pressure is also decreases. So this type of line is formed. I am taking second component, B component. For B component vapor pressure, PB0 here. The vapor partial pressure of is PA. PA line is here. It is long. Here XB is equal to 0. It gradually increases towards right hand side. Here XB is equal to 1. Mole fraction of the component B. If the mole fraction of B increases, partial pressure also increases. This is for PB. Now both are mixing together to form this line. This belongs to PA plus PB. Total pressure. P total is equal to P total vapor pressure is equal to PA plus PB. This is the PA plus PB line. This is a graph to explain the Raoults law for two volatile liquids. Okay. Now I am taking a problem. Previous year question. T by Q. Reverse equation. Here 7.8 grams of benzene is mixed with 9.2 grams of toluene to form a solution. To give a solution. The pure vapor pressure of benzene P0B is given as 400 millimeters. 400 millimeters. 400 millimeters of Hg. And P0 toluene, pure vapor pressure, is equal to 200 millimeters of Hg. Now calculate the total vapor pressure of the solution. I am taking the formula P total is equal to, there are two liquids, benzene and toluene. Volatile liquids, both are Pb for benzene. P0B into Xb plus P0T, T for toluene, and Xt. Using this formula, you have to calculate total pressure of the solution, vapor pressure of the solution. Here Hb, zeta B, is equal to number of moles by benzene by number of moles of benzene plus number of moles of toluene. Number of moles of benzene is calculated by using weight by gram molecular weight formula. Weight of the benzene is already given 7.8. And gram molecular weight of benzene, molecular formula is C6H6. Its molecular weight is 78. 0.1 moles obtained. In the same way, number of moles of toluene, we have to calculate it by using this formula, weight by gram molecular weight of the toluene. Here 9.2 grams of toluene, 9.2 grams, weight of the toluene is 9.2. The gram molecular weight of toluene formula C6H5CH3. C6H5CH3. Gram molecular weight is 92 grams. Here also 0.1 mole. Okay. All these values are substituted here. Xb is equal to 0.1, Nb is equal to 0.1, Nb is equal to 0.1, and it is also equal to 0.1. 0.1 by 0.2 is equal to 1 by 2. Next Xt. Xt is zeta T. Number of mole fraction of toluene. Number of moles of toluene by number of moles of toluene plus number of moles of benzene. 0.1 by 0.1 plus 0.1. 0.1 by 0.2, that is equal to 1 by 2. P total is equal to P0B, already given here, 400 into its mole fraction Xb is equal to 1 by 2 plus P0T is equal to 200 into mole fraction 1 by 2. 2 cancel, 200 times 2 cancel 100 times. 200 plus 100 is equal to 300 millimeters of Hg. This is the total vapor pressure of the solution, 300 millimeters of Hg. Okay. Now I am taking second form of Raoults law. First form of Raoults law completed, problem also completed, graph completed. What is the Raoults law for first form? The partial pressure of a component is directly proportional to the mole fraction of that component in the solution. This law is applicable for if the two components are volatile. Now second form, Raoults law. It is for non-volatile solute. One of the component is non-volatile. Volatile and non-volatile. Volatile substances are vaporizes at room temperatures. Example H2O, acetone, petrol, and chloroform, and etc. These are vaporizers at room temperatures. Non-volatile substances means the non-volatile substance cannot vaporize at room temperature. They require some temperature to vaporize. So there are two liquids, or one liquid and one solid is there. Solid is a non-volatile solute. Okay. Raoults law, I am taking statement. The relative lowering of vapor pressure of a dilute solution containing non-volatile solute is equal to the mole fraction of the solute. In the solution. It is called Raoults law. Here RLVP is equal to RLVP means relative lowering of vapor pressure, which means the ratio between LVP and lowering of vapor pressure and pure vapor pressure. Lowering of vapor pressure formula, that it is the difference between vapor pressure of pure solvent and solution. P naught A minus PA. This is called LVP, lowering of vapor pressure. It is divided by P naught A. It's called relative lowering of vapor pressure. But we know partial pressure PA is equal to P naught A into XA. In the place of XA, you have to substitute that. PA naught minus PA naught XA by PA naught. Here, this is cancelled. 1 minus XA is there. And we know that another formula, XA plus XB is equal to 1. Mole fraction, total mole fraction sum is equal to 1. I need XA, 1 minus XB. So 1 minus XB. This one cancel, minus into minus plus XB. Finally, we got P naught A minus PA by P naught A is equal to xp. Xp is the mole fraction of the solute, not solvent, solute. So here xp is equal to mole fraction formula, number of moles of solute by number of moles of solvent plus number of moles of solute. For very dilute solutions, NB is small, far lesser than Na, and compared with number of moles of solvent, number of solute will be neglected for very diluted solutions. So NB plus Na is taken as Na. The formula write here NEB by Na. NB is equal to solute weight by solute gram molecular weight. Solute numbers to gram molecular taken as like that. And solvent, it is reverse, it is M1 by W1. Total value substituted here. P naught A minus PA by P naught A is equal to W2 by M2 into M1 by W1. This is the mathematical expression of Raoults law for non-volatile solute. By using this formula, we have to calculate molar mass of unknown solute. M2 is the molar mass of the solute. So the formula converted for M2 is equal to M2 here and this one here. M2 is equal to W2 M1 by M2 W1 into P naught A by P naught A minus PA. So this formula is used for calculation of molar mass of unknown solute. And one more thing is there. This Raoults law is applicable for only very diluted solutions. The condition is, the limitation is, Raoults law is applicable for only very diluted solutions. Thank you.